The feed platform team, we create the infrastructure that powers all the infinite scrolling feeds that you see in the Facebook app. This includes news feed, timeline, groups feed, search, etc. And one of the things that I've learned from working on the team over the past few years is that even though the premise of feed seems simple enough, getting everything to render seamlessly and efficiently is complex. One of the reasons for this is that feed displays lots and lots of different formats, and the implication of this is that we have an endless number of view types to recycle. We also support embedding rich content such as 360 photos and videos, autoplay videos, horizontally scrolling view pagers, and sometimes videos inside of view pagers. There's also a number of ways that each feed can be updated, such as doing a pull to refresh, scrolling down, interacting with an individual story. And now with the efforts of my coworkers, Omer, Jason, and Jingbo, we've updated the feed architecture from ListView to RecyclerView. So this was a pretty big investment for us. And before we got started, we had some big questions. The first one being, why should we upgrade? How exactly is RecyclerView different than ListView, and what are we going to gain by using it? And then the second question is, how are we going to go about this upgrade given the size of our code base? So let's start with some of the differences between the widgets. You can think of RecyclerView kind of as ListView 2.0. It's not backwards compatible per se, but for the most part, it covers the same use cases. One of the major improvements is that the internal architecture of RecyclerView is broken up into a number of smaller, somewhat independent components, and this allows for greater customizability. And the biggest example of this is that the layout manager, which is responsible for laying out the views on the screen, is separate from the component that recycles the views. And the implication of this is that unlike ListView, which only supported a few layout types such as grid and list, the layout manager for RecyclerView can support all different types of scrolling layouts. Android has officially released 3 different ones, linear, grid, and staggered grid, but there's a number of other ones available in open source libraries. RecyclerView also added support for animating row items. At the talk at Google I/O 2016, the engineers who work on RecyclerView said that animations were the main reason they decided to completely deprecate ListView and start over again from scratch. The reason being that in ListView, the adapter just doesn't provide enough information to do smart item enter and exit animations. And so this is fixed in RecyclerView, and there's some pretty complex logic that determines that once this second item disappears, then a new item needs to be added onto the bottom to fill in the empty space. RecyclerView has some API improvements that simplify the coding experience. In ListView, the adapter was required to implement getView, and that returns a bound view for the given position. It was the adapter's responsibility to reuse the second argument, the convert view, which is passed in from the recycler, or the adapter has to create a new view from scratch if the convert view is null. But the problem was that if the adapter was poorly implemented and neglected to use the convert view, then it was pretty much missing out on the entire reason that ListView was created. So in RecyclerView, view creation and view binding are split out into 2 methods, onCreateViewHolder and onBindViewHolder. And this is actually one of the few places that RecyclerView is just conceptually not backwards compatible with ListView. So I'll talk about this more when I cover migrating to RecyclerView. And then RecyclerView also uses the efficient holder pattern by default. This isn't a new pattern. You could have used it in ListView if you wanted to. A view holder is an object that stores references to a row's subviews, and these are the views that have been found by findViewById. And the reason for doing this is that findViewById, whenever it's called, is going to do a slow tree traversal of the view hierarchy. And that's slow, so it makes sense to cache the results in the view holder. Especially since when onBind is being called, the UI frame, the UI thread is under pressure to render the current frame on time. Another new concept in RecyclerView is the distinction between adapter and layout positions, and this fixes undefined behavior in ListView. You can think of adapter positions as the position of items according to the data set, And you can think of layout positions as the positions of item according to what's on screen in the view hierarchy. Most of the time, these two positions are exactly the same. They will only sometimes differ for a brief period of time, and that's from the moment that the adapter has been notified of a dataset change until the next layout pass. And so during this period, the adapter will be aware of changes that are not yet reflected in the view hierarchy. So it's important to watch out for race conditions when you're trying to convert between view positions and adapter positions, and this most likely will happen when you're calling like getChild adapter position or find view holder for adapter position in between the notify and the layout pass. Another big difference in RecyclerView has to do with how dataset changes are handled. Whenever there is a dataset change, the adapter needs to be notified that that change has taken place. In ListView, there was only one method, notifyDataSetChanged, but now in RecyclerView, not only is there notifyDataSetChanged, there's a bunch of new methods that specify exactly what has happened. So what are the benefits to using these more descriptive methods? The first is with respect to the adapter and layout positions that I just talked about. If the positions are different, RecyclerView will be able to convert in between them, but only if the granular notifies are used. If you call notifyDataSetChanged at all, then it won't be able to do this conversion until the next layout pass happens. Second reason is that it powers item animations, which, as I said, was one of the main motivations for creating RecyclerView. It's the best way to ensure that your scroll position is maintained during any sort of dataset change. And then finally, it's just a lot more efficient. The reason for this is that notifyDataSetChanged will cause both ListView and RecyclerView to unbind every single view that's on screen and then rebind it, even if some of those views that are getting rebound haven't changed at all. If your item views are complex, like, such as in newsfeed, then it's going to take a long time to do this rebind. But if you use the granular notifies, this ensures that only added and changed views will be rebound. And when we converted to RecyclerView and started using these granular notifies, we were able to measure one of our biggest scroll perf improvements ever. But there is an interesting caveat, which is now that a bound view might be reused in multiple positions in the RecyclerView. So it's important not to save the position that's given to you during unbind inside of the view holder. As you can see in the code sample, IntelliJ or Android Studio will give you a lint warning. But really, you should be using either holder.getLayoutPosition or holder.AdapterPosition to get the most updated position. And there is one major downside to using the granular notifies, and that's complexity. Because in the past, we've had to deal with a number of bugs where product code would forget to call notifyDataSetChanged when it's appropriate. But now that there are multiple methods, the risk of an error goes way up. And if you call the wrong notify, you'll get a crash that is similar to this picture here. And if you look it up, you'll see that a lot of people are running into the same index out of bounds exception that is originating from inside of the RecyclerView. And this ticket is technically closed because it's due to developer error calling the wrong notify, but even if you know the exact reason for the exception, it still can be pretty difficult to solve it. So to avoid these crashes, you probably want some sort of data set that automatically outputs the changed events for you. The support library has two such classes, and they're worth talking about because the RecyclerView documentation just completely neglects to link to any of them. The first is sorted list, and this maintains a sorted list of items, and whenever that list mutates, it emits callbacks for the changes, and then those changes can be sent to the adapter. The second is diffutil, which, given two lists, outputs the most optimal change set between them, and this change set can also be forwarded to the adapter. Although I'm not aware of anything that works with cursors to generate these granular notifies. So I think those are most of the major differences between ListView and RecyclerView. I want to talk about some more of the subtle differences that you might not realize until you've used both of the widgets a bit. The first is just that ListView is part of the Android SDK, which ships on the device. And this means that if you run into a bug, there's very little you can do about it except for maybe try to come up with some sort of workaround. Just one example, we noticed that if the user flings multiple times on the same scroll, then the on-scroll listener will be called multiple times on the same frame, once for every fling, and this actually has a pretty detrimental effect on scroll performance. On the other hand, the RecyclerView library is in the support library, so that means it's constantly being updated by Google. And if you look up the issue tracker for RecyclerView, you'll see that there have been a lot of bugs, but that's to be expected because pretty much all code has bugs. But the real positive is that these issues are being fixed and they're constantly being sent out in support library updates. Another limitation of ListView was that it required view type IDs to be sequential and that the total number of view types be known ahead of time. And so when you start to have hundreds of view types, such as in feed, then this becomes a performance concern during activity creation. And so now in RecyclerView, there's no longer this requirement, and view types just need to be unique IDs, which means that you can actually use resource IDs, which are unique as the view type. ListView had view height-based recycling, which was kind of awkward. It determined the number of items per view type to keep in its recycle bin based on the number of views on screen. So this recycler strategy worked great if all of your items are of consistent height, but on the other hand, it causes a lot of thrashing if the ListView displays items of varying height. When a really tall item enters the ListView, it's going to evict recycled views from the recycle bin, even if they're going to be needed later. The policy in RecyclerView is much simpler. The number of recycled views per view type is just set to a constant 5, and it can be changed if desired. One thing that might be surprising about RecyclerView is that it's actually missing a few of the features that ListView used to support. As can be seen by the popularity of this Stack Overflow post, a lot of people are wondering what happened to on-item click listeners. And that used to be a listener that was set on the ListView that got applied to all of its children elements. And this was deliberately kept out of RecyclerView because it confusingly conflicts with click listeners that are set on the child views directly. Another missing feature is header and footer views. This displayed content before and after the rows provided by the adapter. And then there's also no empty view, which was a view that appeared when the adapter was empty. And then there's also one area where we've noticed that ListView performs a little bit better than RecyclerView, and that's with handling embedded videos and texture views. The reason for this has to do with how TextureView, ListView, and RecyclerView all handle view detachments. And so starting with ListView, when a view leaves the visible area, ListView will temporarily detach the view and place it in the recycle bin. And this actually breaks the contract that is described in ViewGroup, which says that temporarily detached views should be fully removed within the same frame. And so perhaps the motivation for this was that it's more efficient. It can be kind of dangerous because now there's a lot of views sitting around in the recycle bin that are holding on to a lot of native resources. So RecyclerView fixes this behavior, and it does a full detach immediately whenever a view leaves the screen. But there is one major downside to this, which is that when onDetach is called, it's going to destroy the surface in the texture view, and then when that texture view is ready to be scrolled back on screen, it's going to take some time to recreate the surface, and this can cause your video view to flicker a bit. So one way to get around this is to create a custom recycler that prevents videos from being detached. You can use RecyclerView's view cache extension interface, but this gets to be a little bit complex, and we haven't really found a solution that works perfectly. So I think that's enough for differences. Now it's time to talk about how to migrate from ListView to RecyclerView. And I guess one way to think about this question is how to migrate to RecyclerView without breaking everything. So the top diagram is just a simplification of the tree of logic that we use to render a single story in feed. And then the picture below that is the actual diagram that I pulled recently from our code base. And so as you can see, there's just like a massive number of classes that are built on top of the feed architecture. And the point of showing this is just to say that there's no one person who knows how everything in feed works. We also release a new version of the Facebook app every week. So we can't just like hold off the next version of the app until we're done rewriting every feed in RecyclerView. The app always needs to be in a working state. And then finally, our code base is shared among hundreds of Android developers, which means that other people are trying to write new code at the same time that we're trying to change the underlying implementation. So we can't just lock down the whole repo until the conversion is complete. The Facebook engineers that you see here are happy enough right now, but if we get in their way, they won't be so happy. So the way to get around these complications is to set up an A/B test. We can work on the RecyclerView implementation while ListView is still being used in production. And then once the RecyclerView version is ready, we turn on a test. So some people will be running feed with ListView, some will be running feed with RecyclerView, and if we do it correctly, no one will be able to tell the difference. But in case we didn't, we can use the A/B test to detect any new bugs or new crashes. And we can also measure scroll performance regressions, which we care a lot about. At last year's Droidcon, Jason Sendros is over there, gave a talk about how we measure scroll performance in production. So you can check out his talk at fb.me/road to 60fps if you're interested in learning more about that. So the way we decided to carry out this A/B test is that we have a migration library that abstracts away whether a scrolling view is implemented in ListView or in RecyclerView. And then we can reuse this library for every feed that we want to convert. In this class diagram, scrolling view proxy is the opaque interface that has the two implementations, ListView proxy and RecyclerView proxy, and those wrap their respective scrolling views. And so the way that this works is that scrolling view proxy has all the same method signatures as ListView, so it's easy to swap it in. And then RecyclerView proxy is doing all the heavy lifting of mapping ListView methods to RecyclerView methods. And then to make the migration easier, we backported some of the missing features from RecyclerView, such as the on-item click listeners and the header and footer views, and those are implemented in the RecyclerView proxy class. So if you want to take a look at some actual code, we have a sample version of the migration library that we used in production. It's available on GitHub at /fpsample/listView to RecyclerView. So I encourage you to check it out. And so the first step to using this library is to break up the getView method inside of your ListView adapter into a createView and a bindView method. And as I mentioned before, this was one of the few places that RecyclerView was not conceptually backwards compatible with ListView. But once you do this step, you'll actually be able to use your ListView adapters inside of a RecyclerView. And then the second step is just to replace all the code references to ListView with the scrolling view proxy instead. And as I said, this step isn't that hard because all the method signatures match up. And then finally, you should have layouts for both ListView and RecyclerView so that depending on which version of scrolling view proxy you're using, you can inflate either one of them. And that's pretty much it. Once the RecyclerView version is working, you can start to remove the scrolling view proxy so that you don't have an extra layer of abstraction. And now it's time to convert the ListView adapters to RecyclerView adapters. The reason for doing this is to get the benefits of the Granular Notifies. But also you need to get rid of all the notifyDataSetChanged calls in order to get those benefits as well. And I recommend throwing a runtime exception if anyone tries to add a new notifyDataSetChanged call. And then finally, once you're using the Granular Notifies, you can create some interesting animations for your list. So in conclusion, why switch to RecyclerView? Both ListView and RecyclerView are large widgets and that support lots and lots of different features, and everyone's application is going to use these widgets a little bit differently. And in this talk, I've been biased towards the features that we care the most about at Facebook. But nevertheless, I think there are some larger themes where RecyclerView shows that it's better than ListView. And the first is extendability. The internals of RecyclerView are designed in a modular fashion. and this allows for greater customizability. The second is stability. RecyclerView fixes a number of bugs that were in ListView, and newer versions of RecyclerView are constantly being updated. And then the third is performance. RecyclerView is just a lot smarter about handling dataset updates, and this in turn powers complex animations. All right, so thanks for listening. If you have any questions. Yeah, all the talks are recorded. Yeah, so I don't think we're using any. Yeah, so the library that we're using was mostly built internally. I don't think we're using anything that is open source, as far as I know. Yeah, you can target based on like app version.
So on the Facebook newsfeed, like how do you know the percentage of the view that's actually visible to actually autoplay views? Like what's your logic behind it?
Well, you know the height of a view once it's been found.
So you mean the get measure type would actually give you the height of the view, and you calculate the percentage of it visible compared to your data?
Yeah.
And at what percentage do you start playing the video?
I don't know what the constant is.
And how do you know when to stop?
You have to do the, I'm sure you can figure that out just by testing it. In the back.
Have you had to experience anything in the migration using cursor adapters from ListView to RecyclerView?
Yeah, we weren't using cursor adapter. But yeah, I think that's a pretty undefined part. I'm not sure what to do there.
How did you get around the problem of texture making a contact with the recycler? It kind of goes through its own data cycle.
Sorry, I can't hear.
How do you get around the problem of the texture making a contract with the recycler?
Essentially by making a custom recycler that is specific for video views.
Oh.
And that recycler keeps the views still attached to the recycler. Yeah.
Is that available on the open source?
No. Yeah.
So you mentioned Intertil as a tool to basically be able to figure out sort of if you get a new updated set of data, what specific points on that list you should only update so that you can get to the minimal number of UI changes. Are there any issues with running multiple of those at the same time, or can RecyclerView basically sort of you just sling in a list of update, change, remove, and it'll handle all the UI updating of that, or is there any sort of post animation on animation finish things that need to be done?
I know that one of the issues is just that it's kind of slow to run getView. There's a lot of, the list is large and there's a lot of changes. Whereas sorted list,
That's easier to check.
yeah, it's doing the changes one by one.
So yeah, say you did sort of list instead. Yeah, I guess my question is more like, would there be any issues in just basically running several different like item remove at the same time, or is there something that you should like wait for in the middle of that? Or
The only thing I'm aware of is just the performance of doing that. You can batch removes if they're all next to each other.
yeah. I mean, I'd be more thinking if there was sort of an updated set of data that had quite a few different changes within it, such to the point where you wouldn't want to just sort of throw it all away and do it just everything update. You want to sort of do a more specific assessment. I'll take a look.
All right, thank you.